Welcome back, smart mathematicians. Let's do question 5.2. Right, it says prove the identity, and then we have this identity with the left hand side and the right hand side. And then if you check on the left hand side, that's where we have our left hand side is more complicated, so it means we have to work on it. Okay, right, so let's look at the numerator and then the denominator. If you look at the numerator here, we have sine squared x and then cos x. Right, so can we change sine squared x to cos squared x? Yes, we can change that. We can change that, okay? But we can't change cos x to sine x, so we can change this one to cos squared x so that we have the same trigonometric ratio. And then here we can see that we have an angle which is greater than what? Which is greater than 360 degrees. Okay, so let's try to work on those. Let's start with the numerator. Remember from grade 11, remember that cos squared x plus sine squared x is equal to 1. And then from that we can see that sine squared x is equal to 1 minus cos squared x. Okay, do you remember that? So we're going to replace this with 1 minus cos squared x. Let's just do that. So it's going to be negative 2 and then 1 minus cos 1 minus cos squared x, and then plus cos x plus 1. Right, all this over. And then we have angles greater than 360 here. Remember that cos 360 degrees plus theta is equal to cos theta. Okay, right. Then now if you check 540 is one complete revolution plus 180 degrees. So we can say this, let me just write this, cos 540 minus x is equal to cos 360 degrees plus 180 degrees. If you check 360 degrees plus 180 degrees is what? 540, and then minus x. Okay, right. And then we say that using this, okay, so this is our 360, so it means this whole thing here is just the same as our theta here. It's equivalent to the theta here, okay? So this is equal to cos 180 degrees minus x. You see that? And then which is in which quadrant? This is in the second quadrant. This is in the second quadrant. 180 minus x, 180 plus x, 360 degrees minus x. We see that. So it is in the second quadrant, and in the second quadrant, our cosine of the angle is going to be negative. So this is equal to negative cos x. You see that? Okay. So we have this reduces to negative cos x. So it becomes 1 minus negative cos x, and then is equal to 2 cos x minus 1. Okay, you always write your left hand side and right hand side, because sometimes you have to work on both sides. It's not like you have to work on one side every time. Okay, sometimes you have to work on both sides. Right, let's dispute negative 2. Negative 2 times 1 here is negative 2. Negative 2 times negative cos squared x is positive 2 cos squared x. Then plus cos x plus 1. And then all this over. Then we dispute negative here is going to be 1 plus cos x. That is equal to 2 cos x minus 1. Okay, here we can get our standard form. Okay, we can get our standard form here. So it becomes 2 cos squared x plus cos x. Then negative 2 plus 1 is negative 1. And then all this over 1 plus cos x. is equal to 2 cos x minus 1. Okay, right. So we can factorize this. Sometimes if you think maybe you make this one more algebraic, you can do that. Like we can say 2, let's make cos x be x. So it's like 2x squared plus x minus 1. I mean the top part, this part, numerator. And then we can factorize this. What is 2 times negative 1 is negative 2. We look for the factors of negative 2. Any method that you can use is fine. You look for the factors of negative 2 that can give us what? Positive 1. That would be positive 2 and negative 1. So it's 2x squared plus 2x minus x minus 1. You see this? Okay. And then we can factorize that. It becomes 2x and x minus plus 1, then minus 1, x plus 1. You see that? Okay. Then we have 2x minus 1 and then x plus 1. Okay. Right. Remember this x is like our cos x. Okay. So if you can do this part without doing this is fine. Without doing this is fine. You can do it straight away. Right. So let's just factorize that. So it becomes 2 cos x minus 1 times cos x plus 1, all this over 1 plus cos x is equal to 2 cos x minus 1. Right, and remember multiplication and addition and multiplication are what? Are commutative. So it means cos x plus 1 is just the same as 1 plus cos x, isn't it? So this is just the same as this. So say cos x plus 1 divided by 1 plus cos x is 1. So we remain with 2 cos x minus 1 is equal to 2 cos x minus 1. We have proved that the left hand side is equal to the right hand side. Okay, right, done. Okay, right. So that's what you're supposed to do there. We're going to meet when we do question 531.